So first is drawing. So we'll see the Lewis structure being drawn and depicting molecular formulas, but that's not necessarily the only thing that we'll see. As at a very basic level, when we see a bond drawn as a straight line like this, it is representing a bond on the same plane of the page. This dashed line indicates a bond drawn into the page, and this triangle indicates a bond coming out of the plane of the page. Now, what you see all of these molecules here is that they're all actually the exact same molecule. There's no difference between any of these. The difference is in simply how they're being projected, how they're being drawn. And so you should be able to look at each and every one of these structures and be able to recognize that, in fact, these are all the same. Okay? So that's something that you should be comfortable doing. Now, the Fisher projection and the Newton projection are very specific structures, and they're going to have very specific rules around how we interpret them. So we'll discuss that, but not quite yet. The first thing that I want to really get into with organic chemistry is nomenclature. So you will need to be able to interpret a structure that's given. That is, they give you some structure, and you should be able to figure out what the name of that might be. And you're never going to see any very complex structures here. It'll all be relatively straightforward. And you should be able to take a name and interpret what its structure might be. Okay? So you should be able to go forward and backward with this content, with nomenclature. Now again, they're not going to give you anything that's incredibly complex, so you don't have to worry about seeing very, very large, obscure structures. But in general, you should be comfortable understanding this process. So we have a 5-step process here. We call it iname. First, we identify the longest chain. We then number that chain. We will assign names to the substituent groups, number each one, and then execute the naming. So the first step, identifying the longest chain and numbering it. Suppose we have this large organic molecule here. We want to first look for the longest chain. So is it this chain, or is it this chain, or is it this chain? Okay, it's the pink one. It has the largest number of carbon atoms. And so the next question is, which way do we name it? Do we name it starting with 1 over here, or do we name it with 1 starting over here? So the rule here is that you want to have the lowest number substituents. That is, the first number that shows up should be the lowest, as low as possible. So here we're going to start with 3. Here we're going to start with 5. So we're going to go with the left one. Okay. So we start from the left end, and now we want to assign names to the substituents. So we have a methyl group coming off of the 3rd carbon, an ethyl group coming off of the 5th carbon, a propyl group coming off of the 6th carbon. We need to number each of those substituents. So we have a 3-methyl, a 5-ethyl, and a 6-propyl. And then to execute the name, we have to actually put that together. So the name assembled is 5-ethyl, 3-methyl, 6-propyl decane. Now, you'll note that these are not in numerical order. These are actually in alphabetical order. E comes before M, comes before P. And so that's how you're going to see the nomenclature show up. It's not too big of a deal for your purposes because they're really not going to be testing you explicitly on the naming rules. So, if you, let's say, forgot that, you would still not end up with the incorrect answer because you'll still be able to recognize that the correct answer is the only one that has 5-ethyl, 3-methyl, and 6-propyl decane in whatever combination. Okay. The questions are never explicitly about nomenclature rules, but they may test you on just your recognition of names and your recognition of structures in correlation to names. Okay, so I'm going to show you some examples of what that might entail. Other rules that are important to keep in mind around the alphabetizing the names is that prefixes, certain prefixes are alphabetized. Okay. Certain prefixes are alphabetized, others are not. So iso and cyclo are alphabetized. Also neo, but you're not going to see neo on the MCAT. Or at least you don't have to know it for the exam. Iso and cyclo are alphabetized as I or SC, so isopropyl would then come before the ethyl. But the numerical ones or other structural ones like di, tri, tert, sec, these are not alphabetized. So a dipropyl would still be alphabetized as a P rather than as a D. Some functional groups, that is alkyl functional groups, that you should be able to recognize. These include tert-butyl or T-butyl, sec-butyl. I like to remember T-butyl because it looks like the letter T. It's this cross like this. Sec-butyl comes off of this second carbon. Isobutyl reminds me of isopropyl. They both have the branch at the very end. So here's isopropyl. Phenyl groups you should recognize as basically benzene rings as the functional groups. And then we have our alkenes and our alkynes. Alkynes are pretty straightforward. They are linear bonds, as we saw in general chemistry. They're linear bonds, and so they don't have any specific stereochemistry that we have to worry about, or shape chemistry, or specific nomenclature around their structure, as we do with alkenes. So alkynes are pretty straightforward. For example, 2-hexyne or hex-2-ine. We know it's a linear bond, and so there's nothing added that's more complex there. Alkenes do have some extra nomenclature that we need to worry about, the E and Z nomenclature. So these come from German. E indicates that they are both on opposite sides of this double bond. Z indicates that they are both on the same side of the double bond. Okay? And you can sort of remember this by saying this to yourself in a German accent, the Z's are on the same side. So with that, I know that the Z's, when it's Z, these primary functional groups are on the same side. This can get more complex. So what if it wasn't just an alkene like that? What if there were, I don't know, a chlorine atom and a methyl group like this, and then I had an ethyl group here and an OH group here. Okay. We're going to go based off of the numbering that we use for stereochemistry. And I know we haven't talked about that yet. We're about to. So we're going to use the exact same numbering that we're about to use for absolute configuration. And so it turns out that these are the two primary functional groups. And so because they're on the same side, this would be E. Okay. So the EZ notation is a little bit more robust than the cis-trans notation, which you may have learned. The cis-trans notation is typically reserved just for alkenes with no other functional groups. So for example, this would be cis because they're both on the same side. Trans would be they're on opposite sides. But it specifically refers to alkyl groups, and so in that sense, it's a little bit convoluted and potentially misleading. So we avoid that unless we're just talking about alkenes like this. Okay? You'll see that, for example, in the discussion of fatty acids. So We have our halides, chloro, fluoro, iodo, bromo, our thiol groups, or our SH groups, alcohols, nitriles, ethers. You should recognize all of these and know what functional group they are. And then we have, below this line, all of these functional groups. You'll notice that they all have the carbonyl group, which is a C double bonded to an oxygen. Okay. And to some extent, that's really insightful for us in terms of understanding why a lot of the reactions that they'll undergo are highly interchangeable. And we're going to talk more about that in the next organic chemistry lecture. And we're going to talk more about the specific reactions that each of these types of functional groups will undergo. But recognize for now that there's actually a relatively minor difference between each of these. Carboxylic acid has the carbonyl, but then it has just the OH group here. And ester has an OR group. An acid halide has just a halide there. An amide has an amine. Aldehyde just has an H. Ketone has an R group, okay, some alkyl group. And so there's a great deal of interchangeability, a lot of similarity, and there are some dissimilarities between the physical properties and the reactivities of a lot of these functional groups.
For most students, and maybe you too, the CARS is the hardest section on the MCAT. It may feel like it's one of the few remaining obstacles between you and the medical school of your dreams. But as you try to prepare for the CARS, you find there is a never-ending stream of conflicting tips, strategies, and plans, none of which seem to actually help or show any results. If you feel frustrated, overwhelmed, or lost when it comes to the CARS, if you're looking for a CARS expert who has helped thousands of students achieve their MCAT CARS goals, then you found your solution. Testing Solutions MCAT CARS Bootcamp. Founded by Nick Zahner, a current medical student at Stanford with a master's degree in philosophy of religion from Harvard, Testing Solutions' approach to the CARS is revolutionary. Testing Solutions CARS Bootcamp provides day-by-day, step-by-step instruction that teaches you the techniques that produce ultra-high MCAT CARS scores. Instead of wasting your time with the needlessly complex filler that other companies try to sell you, Testing Solutions' approach to the CARS is based on the principle of minimum effective dosage. There's no wasted time, just the minimum amount of effort that is required to get you the results you want. With over 500 4.5-star reviews on Amazon, Testing Solutions CARS Bootcamp is the most trusted, proven, and effective CARS course available on the market today. You will have access to Testing Solutions' 180 meticulously designed CARS passages, the largest CARS practice library offered by any MCAT prep company in the country. Our passages are regularly rated by users on Amazon, Reddit, and SDN as the most accurate non-AAMC CARS practice passages available, consistently rated higher than Exam Crackers, the Princeton Review, Kaplan, and Next Step. Unlike some companies who prey on pre-medical student fears by charging outrageous amounts of money for their mediocre at best practice materials and courses, Testing Solutions will always charge a fair price for an amazing product. Because after all, we're not like the other test prep companies. We're aspiring doctors just like you, only a little further down the path. Let us help you do what we've already done. If you're not happy with your CARS Bootcamp for any reason, we offer a 100% money-back guarantee, no questions asked. You've got nothing to lose and the CARS score of your dreams to gain. Don't be one of the people who write us each week saying they wish they had found our MCAT CARS Bootcamp sooner. You don't have to struggle with the CARS any longer. Sign up and get started today.